1/4.
With 1/4. And then always recommend using point slope form. If it doesn't specify,
Okay.
make them deal with this. So it's y minus 1 equals 1/4. X plus 1 is your final answer.
Okay.
There's almost no way to check it, so don't don't, there's no, even if the calculator would be kind of tough.
Yeah.
Any questions on that?
No.
Oh boy. Okay. Number 2. So I want to grab this line for number 2. So when you're taking a second derivative implicitly, you basically have to do two things. The first is what we did in the previous problem, which is you solve for dy dx. So you have that here off to the
Okay.
side. Like you've already done that, but you actually split. You actually take a look at the equation twice. The second thing you do is you take the derivative of this equation, but you um, just keep going. Okay, so it's another product rule over here. And I think you're what did you do here? Are you a keep the first? Yeah, you're a keep the
Oh,
first. Okay.
yeah.
All right. So it's 3y squared, d squared y dx squared. That's the second derivative. Plus 6y dy dx times dy dx. So that is everything from this right here.
Okay. Okay. 6y. Wait, why do we have two dy dx's?
First one comes from the derivative of 3y squared. Second one
Okay.
comes from this. And just to be
Okay.
clear, these are not the same. Like d squared y dx squared and dy times dx dx. They're not the
Yeah.
same. Now, the
Mm.
second one is also a product rule. Whenever it's a minus, it might be good to put in parentheses. So keep the
Yeah.
first d squared y over dx squared plus 1 dy dx minus dy dx equals 0.
Okay.
This is awful. College students don't even get problems like this. It's definitely not
Do
a
we
grade
leave,
B.
we leave it like that?
No, no, definitely not.
Okay.
We got a lot more to do. This is
Okay.
horrible. All right. So this right here, this becomes dy dx squared, which is not the
Okay.
same as d squared y dx squared. I'm pointing that out because it's easy to make
Mix
that
that up.
notational.
Yeah.
Yeah. Minus dy dx. Okay. All right. So now you move anything that's not a d squared y dx squared term over to the other side of the equation. So it's a little weird. It's really two of the dy dx is -2, so you add it. So when you add it, you get 2 dy dx on the right. Is that clear?
Okay.
That comes from this first one.
Yeah.
And then you subtract 6y dy dx squared like that.
Okay.
And then on the left, it helps to do as much of this as you can without having to rewrite. But I would have factored it out here. But you're going to factor out d squared y over dx squared from both.
Okay.
No, there's no calculus again. Like calculus is over. This
Yeah.
is just manipulating. It's really just an awful literal equation kind of stuff you see in a math movie. Um, then you divide by 3y squared minus x. All right, and there you go. Now you feel like you've got it, but you're not done yet.
Okay.
You're like, what? There's more? Yeah, there's more. So you have to substitute for dy dx. So your dy dx from the previous problem is right here. The joys of calculus. So this is all going in for DOI dx. So it's 2y over 3y squared minus x minus 6y y over 3y squared minus x squared over 3y squared minus x. All right. Now, I don't know, your person who, well, that's completely wrong. Yeah. So this looks really complicated, right? Like you're supposed to put in -1 and 1 in, but you already have the answer for this if you did part A correct. Part A was 1/4. That's
Yeah.
2 times 1/4 minus 6 times 1 times 1/4 squared over 3 times 1 squared minus a minus 1. Again, it looks terrible, but I kind of already have some of it from first part. 1/2, 6 times 1 over 16 is 3/8, all over 4. So since it being like 4/8 minus 3/8 is 1/8 over 4, which is 1/32.
Oh god. Okay.
A lot of work. Wow.
Yeah. Okay.
Any questions on that before we move on?
No.
Okay. Number 3. All right. Given this equation, if x and y both vary with time, this is the reason this is different than the previous problem. Previous problems, y was a function of x, the other variable. In this problem,
Mm-hmm.
x is a function of t and y is a function of t, which means their derivatives are dx dt, dy dt.
Okay.
So it's like they're both implicit. X decreases the steady rate of 12 units, so dx dt is minus 12, decreases is negative. They want you to find dy dt when x equals 6. The other problem here is you don't have y, so you got to calculate y. You might do
Okay.
that first, because if you can't do that, you might not proceed in the problem. But it's 6y minus 3y plus 2 times 6 squared equals 12. That's 3y plus 72 equals 12. You end up getting y equals 20, -20.
Okay. And then we're using that to find the derivative, right?
We got to
Are
take the
we?
derivative of this now, just like we did in the previous problem, except now the derivative of x isn't 1, it's dx dt. What's x dy dt plus dx dt y? That's the product rule of the first. That's the xy derivative. Is that okay?
Yeah.
Normally it's just 1 dy dx, but because they're both with respect to t. So the next one -3 dy dt plus 4x dx dt equals 0. The main thing is that there's going to be a dx dt or a dy dt appended to every single x and y term.
Okay.
And this is where I think we just decided that you would prefer to put the numbers in at this point.
Yeah.
Don't let me like influence you. I'm just that would be an option here. So x is 6 dy dt plus dx dt is -12. Y was -20. Dy dt is, oh, and by the way, these are way different than the problems in your book. I'm sure you know that by now.
Yeah.
They're way harder. 4 times 6 times -12 equals 0. It actually, like, I don't know if you can do this, but like it'd be easier to look at this thing first and then the lessons from it. I get a better feel of what the instructor is doing based on that, based on the
Okay.
thing you sent over today.
Okay.
So what do we got? 240 minus 3 dy dt minus 72 times 4 is minus 288. So we got 3 dy dt 48 dy dt equals 16. A lot of heavy algebra in that.
Yeah. Okay, that makes sense. Okay.
All right. I mean, you can see we're like 15 minutes into this thing, and it's like there's these are. I mean, how do you do this in an hour? Stupid.
Yeah, and there's a lot of them too. Our tests are like 3 pages long.
Yeah. I mean, how do you get an hour for this or what?
80 minutes.
Okay. All right. This one's a little shorter. Do you want to help me out by taking the derivative of this, please?
Yeah. 2 cosine 2x.
Okay. And then you got to be able to evaluate at pi over 4. What does that become?
Um,
Oh, this you got some questions on this. So it
4.
becomes pi over 2. You ought to at least know those points on the unit circle. Pi over 2 is 90 degrees. What is the x value there?
Oh, it's 2x. That's why it becomes pi over 2.
Yes.
Okay, wait. What'd you ask?
It's at the top here is pi over 2.
Yeah. Yeah.
So what's the x value there?
Um, 0.
Okay. You said, yeah, you ought to at least know those. The rest, maybe you can go friend. 2 times 0 is 0. Um, so the tangent line, slope is 0. You still need the y coordinate, which again means you got to evaluate f of pi over 4, which is sine 2 times pi over 4. Sine of pi over 2 is the y value there, which is 1. So you have the coordinates pi over 4 comma 1, slope of 0, y minus y1 equals slope x minus x1. So if this is correct, they probably don't want it though. They probably want y equals 1.
Wait, what do we need? Oh, y equals 1. Okay.
I don't know what they want. I would leave this. I mean,
Yeah.
I'd make it harder on their teacher in the way he's making it difficult on you.
I
All right. I mean, who wants to grade this? I mean, this is awful to grade.
know.
Teachers complain about not having any time. It's like, well, don't give a 20 problem test
And
for your response.
he's giving us our so our final is like the same length as like our normal test, and he's getting knee surgery, so he won't even be there to like grade them. So nobody knows how he's gonna grade them.
Oh, well, so here's how they do it. Um, with my neighbor's a teacher. They just have another teacher grade them.
Um, that's gonna be
And
very
they either pay them or it's like for that.
yeah.
All right. So 5A, actually, we don't need this table quite yet. We'll get to the table in a moment.
Okay.
5A is K of X equals F of G of X. And okay. So can you tell me K prime of X? Kind of symbolic form.
Um, g prime of x times um f of g of x.
F prime of
F
G of
prime.
X. Yeah. Derivative of the outside function, then multiply by the derivative of the inside function. So now we want this K prime of 3, G prime of 3 times F prime of G of 3. I think it's really important to actually write it in the form and not try to like come up with it on your own.
Yeah.
So could you think this is visible enough? Could you attempt to calculate this for us, please?
G prime 3. I got 10.
Okay. So G prime of 3 is 2 times G of 3 is 6. F prime of 5. I agree, it's 10. Okay, the next thing is to write the tangent line. So we did this because they wanted the tangent line. So you
Yeah.
got the slope. Great. Um, you have x equals 3, and then you also need k of 3. You have to go back to the original for that. So you really need f of g of 3. So could you calculate that for us, please?
4.
That is correct. So basically y is 4. Go back to y minus y1 equals m, x minus x1. Right. There you go. So that's part A. More. Oh boy. Like never ending.
I know.
Oh man. Um, all right. No product rule.
Yeah.
So this is bottom times the derivative of the top minus the top times the derivative of the bottom over the bottoms. Again, I think it's really, really important to rewrite it with the numbers. This is just me talking from helping a lot of students
Yeah.
do this. And if you don't like that notation there, just make sure you maybe use like a bracket or something to show that you're declaring the bottom value. And then you
Okay.
go back to your table. And then what I like to do, get the table, is I like to actually write the numbers kind of above it or below it, rather than rewriting it. Um,
Yeah.
it's easier because I can use a different color, but that would be an option here. That would be also another thing you could do to upset your instructors to use a different color plan throughout the
I
test.
use that for the Raymond sums, how like you do a different one, a different color. I
Yeah.
did that on my test.
Oh, good, good. I like you. You're a little snarky. I like it. So f of 1 is -6. The prime of 1 is 8. That's -6 down here. I hope that's not correct. -42. All right, so something. No, it's minus. I did have it right. All right, so it is -54, and that is -3/2. Okay. Any questions on that? Because that's a lot of work to do.
No, that one's. I just have to remember to rewrite them like out, and then I should be good.
Yeah, like if the teacher were to change this, like they would make this product rule, or they might switch F and G top to bottom.
Yeah.
That's an easy thing to change, and it really doesn't impact the answer that much. Do you ever see different versions of the test typically, or are they
Um,
the same?
the final is literally the exact same questions as like he's picking random questions from our old tests
Okay. Right.
and putting them on the final.
Okay. Okay. All right. Find dy dx. What's he talking? Is the thing in bold here related to?
Oh no, that's not related to the chart.
Okay.
That's related to the next section.
Well, it's not related to 6. You can tell your instructor that.
Um, I actually don't think it's related to anything in the next section. I don't know what
It,
that's
it,
doing there, if I'm
it
being
could
honest.
it could be it could be 7. 7 is the right notation. Again, like this is just little things. Um, I used to have a professor. If you found a mistake in a book or his notes, you get like an extra point on a test. It didn't really matter. It's his way of allowing students to help him, figure out where he made mistakes.
Yeah.
I later realized it was a huge waste of time. So this is a horrible, horrible, horrible practical problem. Okay. Um, do you see that it's a triple product?
Yes.
Do you have to decide like, are you going to make F? And I don't actually know the answer to this to make this like clean. You're going to make that F and G, or are you going to make, this F and this G? Like, it doesn't really matter because one of them you're going to have to deal with, the product rule inside a product rule.
I want
This
to
is
do the
horrible.
forward sign as F.
Okay. So this way, I would probably write this out just to avoid potential mishaps. G prime, the easier one. Do you have the derivatives all memorized by this point?
Oh yeah, oh wait, 5, -5. Cosecant 5x, cotangent 5x.
Yeah. All right. So now the other one here, you're doing a product rule again. So I'll let you tell me the derivative of this, please.
Okay, 24x to the fifth power times sine cubed x plus 4x to the sixth power times 3 times cosine x squared.
Sine squared x first. Um,
Wait, what?
you have it's really sine x cubed, so it's power rule. Said you have to keep the inside function, then multiply by the derivative of sine, which is cosine x.
Oh, 3 sine x. Okay,
Yeah.
cosine x. Okay.
Okay. So now it's just a lot of writing, but your derivative of f prime is pairing up these things diagonally. So you know uh and you do have to simplify. All right. So you might look ahead to simplify that. That would be a thing here to help. Like 4 goes with the -5 to make -20.
Okay.
Sine cubed x cosecant 5x cotangent 5x. And then next one doesn't really, the cosecant's really 1 over sine. It really doesn't that. So it ends up being that there really isn't any simplification here. 9 cubed x plus 12 x to the 6th sine squared x cosine x cosecant 5x. So by the way, when the teachers want you to simplify, it's to make their grading easier. It's not for your benefit, it's for theirs.
If I don't have to simplify, I don't. Like, I don't even care if it says simplify, I just don't do it.
I wouldn't do it. Make them search for answer.
Yeah.
All right. Any follow up to that before we move on to 7?
No, that's good.
Substantially easier. 7.
Yeah.
All right. It's a good one for you to try on your own. Is product rule with chain rule.
Okay. Okay, I got y prime equals 12x cubed times 5x minus 2 to the power of 7 plus 3x to the power of 4 times 7 times 5x minus 2 to the power of 6 times 5.
Okay. Now, do you want to know how to simplify this?
No, I don't simplify.
Okay. Good to set boundaries. All right. I see. Ready? 10 is the next one that I have a picture of. Is that right? Or did you send them all? Maybe they didn't all upload.
Wait, 10 is the next one that you have?
Yeah, let me double check and see what. Yeah, excuse me. Um, Maybe they
Oh yeah,
came in
that's
out of order.
yeah, it's a different like paper. I kind of sent you the ones that like I got wrong.
Yeah.
So yeah,
All
10's
right.
fine.
Then's fine.
Yeah.
Right. 10 is this y equals x tangent x. And all right. So this is logarithmic differentiation. Do you need a refresher on that, or do you want to try this one for us?
I think I can do it. I just added ln to both sides, right?
How does the start? Yes.
Y equals. And I'm taking the derivative, correct? Okay, I don't know how you like plug in the like I don't know how to solve it after I plug in the numbers
That's
to
okay.
it.
That's okay. Can you give me your derivative?
Oh yeah, I did 1y times y prime equals secant squared x times ln of x plus tangent x over x.
All right. So your derivative is secant squared x natural log x plus tangent x over x times x.
Oh, times tangent x.
Now, the
Oh, x.
so, yeah, let's go through it. It's like you took trigonometry, which is okay. Do you remember anything about secant? How to rewrite it?
1 over cosine.
Cosine squared pi over 4. So you ought to at least know that that's root 2 over 2. So it's 1 over root 2 over 2, pairing it. Ends up being 1/2, which is 2.
Okay.
Now, like if I look at how this is graded, like it was 1 point deduction for not calculating the slope, which isn't very much. Natural log of pi over 4, whatever that is, we don't know. And then tangent pi over 4 is 1 over pi over 4. So it's 1 over pi over 4, which is 4 over pi, times pi over 4 to the tangent of pi over 4, which is 1. So, I mean, kind of done. Do you could multiply in. I mean, you could get pi over 2 natural log pi over 4 plus 1. Like you said, you don't simplify. Man, you're nuts.
Yeah, no, I don't simplify. That's like I'm too scared to mess it up. Simplify.
Yeah, it, it's a lot of time to not be sure.
Yeah.
Now, I do remember us working on some of these problems a previous lesson. So if you want me to skip past any of these, let me know. Happy to redo some of these here.
Which one's the next one?
11 is the I'll flip it in here.
Oh, the find the limits.
Yeah, this is
Um,
L'Hopital's rule. I'm happy to do it. I'm just letting you know that it's probably in a previous
yeah, maybe
video.
let's do a review on it. Yeah.
Okay. So you start by evaluating at 0. More trig fun. Cosine of 0 is 1. So you end up getting 0 over 0. It's indeterminate form. So then you have to take a derivative of the top. Can you take the derivative of the top for it, please?
Yeah. Sine x.
Okay. And then derivative of the bottom.
Uh, 2x.
What about the derivative of that?
Oh, 1. Yeah.
Okay. This is sine of 0 over 1 plus 2 times 0, which is 0 over 1, so 0.
Okay. I don't think we have to do 12 though. I think 11. Just 11's good.
Okay. Totally up to you, the customer.
Yeah, I
All right,
think. Yeah.
13.
Yeah.
All right, so in 13 here, we have f of x equals 3x to the 4th minus 4x cubed. It looks like the interval was added in at a later time,
Yeah.
but that's important. So you always start by evaluating at the endpoints.
Okay.
It also looks familiar, by the way, like we've maybe done before.
Yeah, we did do these problems before. Well, not these
Okay,
exact problems, but like it.
just letting you know in case you don't want to do this. The 3 times negative 1 to the 4th, negative 1 cubed. So this ends up being 3 plus 4 or 7. And then 2 is the 48 minus 32, 16. You have to take a derivative. Give me the
12x,
derivative of this.
12x cubed minus 12x squared.
All right, you set it equal to 0. What can you factor out of both?
12x squared.
12x squared. What goes in parentheses?
X minus 1.
Okay. So there's two values here because you're setting them both equal to 0.
Okay.
0 and 1. And then you check to see if they're in the interval.
Okay.
They both are. So they might not be, especially with your instructor.
Yeah.
And see, like I was working with a student taking a business calculus class up in Phoenix, and I was like looking at her questions, like, nope, yours will always be in the interval, and yours, I have to say the other thing, like, well, you got to check. So
Yeah.
you go back and you evaluate f of 0 and f of 1. F of 0 ends up being 0. F of 1 ends up being -1. And you really need the other points. -1 was 7. F of 2. 15. So that's the max and that's the min.
Okay.
You got to justify your answer.
I think that counts as justifying. Like we don't have to like say anything.
Yeah, I don't know what you would do. It looks like you were marked off because you tried to like calculate a point or something. Not sure.
I don't know what I did.
Yeah. I mean, to me, this is pretty clear. So from a grading standpoint, less is actually more. Like this is more meaningful to me. Table.
Yeah.
All right. You want us to do 13?
Um, is it the 2 sine squared one?
Yes. Yep.
No. He took that one off the test because it was like written wrong or something. So we can skip
All
that
right.
one.
Let's see. Another 13. Maybe that's why I was taken off the test. All right. Do you want us to do 13?
Yeah.
Differentiable.
Yeah.
Okay, so there's two things you need for differentiability. It's got to be continuous, which is not the derivative. It's not even calculus. So you put the 2, whatever the breakpoint is, you put that in for x, and you set that equal to the other. The oddity here is that you're putting it in for x, which is it. I don't know, like you're used to somehow like that doesn't work. I've just seen some weird things, but double check that you put that number in for x. On the left ends up being 6. You can see you got 2 unknowns in one equation, so you need to do something more. So you have to take a derivative. So can you take the derivative of the top and the bottom, please?
Yeah. Negative 2x minus 3
Okay.
for the top one. And then for the bottom, 2ax.
Okay. So now you got the same deal. You put that x in. Do the second equation. You get -2 times 2 minus 3. 2 times a times 2. So that gives you 2 equals 4a. So a equals 1/2. And you can use that in this equation right up here. It's all for b.
Okay.
So b ends up equaling like 4.
Whenever I solve for b, oh yeah, okay. Why am
The
I
mistake,
setting
the mistake,
six?
oh good.
Oh, never mind.
The
I see.
mistake you made was just a like, copying error,
Yeah.
um, not actually. See, I might have given you credit for this because you solved your problem correctly.
I might have to go refute some of his grading.
Sure. It's always good to have a dialogue, and that'll become more important in college, to go in there, show that you have a backbone and you're not gonna, because they're people too. They understand, they gotta
Yeah.
do it nicely. Derive the formula. All right. You want us to do 14 or 15?
Um. Actually, yeah, I don't really remember how to do that.
Okay. All right. All right. So if you take the secant of both sides, this is from previous course, you end up getting a secant y equals x, or x over 1. Draw yourself a little triangle. This is y. Secant is really 1 over cosine of y. So if you don't really understand secant, or you wrote like a over 8, maybe you don't remember that, or you can always flip the left, flip the right.
Yeah.
That's 1 over x. And then use Pythagorean theorem to solve for the unknown side. 1 squared plus b squared equals x squared. 1 plus b squared equals x squared. So b equals x squared minus 1 square root. You're like, why am I doing all this? Because you're deriving the formula. So yeah, I'll make the rules. Um, so so the derivative of this, you're going to take the derivative secant for this. I mean, you can go right here too. I mean, if you like the cosine derivative better, that's another reason to rewrite it. So you can use the cosine or the secant. I can't really tell what you did. You happen to know.
Secant tangent. I did.
That's more work. I wouldn't have recommended that, but that's more work. So derivative is, like you said, it's secant y, tangent y, y prime. That's what you're solving for. Equals 1. So you've got to be able to find the secant of y, which is cosine is 1 over x, so it's just x. Tangent of y is the square root of x squared minus 1 over 1 equals 1, y prime. So then you divide by all that stuff there. That's square root of x squared minus 1. I think it actually has an absolute value in front. I have to check that.
Yeah, I think it is.
And probably because we don't know which quadrant we're in. The instructor didn't say. So you can go back and tell them that. You want to point out something, be difficult. Like,
Okay.
specify your quadrants.
Yeah.
All right. I don't, be cautious. I don't actually mean to go into this. This could blow up in your face, but maybe a little bit, but I know your limits. So